So now that we have our interaction ability set up pretty much how we want and working how we want, we can actually write the logic inside of it to drive it. Now, in this case, we're going to be using an ability task. So I'm going to kind of go through and explain what ability tasks are once I go ahead and actually like add it and explain what the purpose is. But we're going to be doing that, and we're going to be adding a simple function that is going to be performing, our sweep. So the idea being to mimic war to war, when we walk up to, say, a buyable barricade, a little prompt comes up on the screen that says, press F to buy blank. And when that comes up, we can press F to trigger the input pressed, and that will go through and continue with the actual purchase. So in order to do that, we're going to be making use of the view model. But in order to have that kind of looping effect that's continually checking to see, if we're interacting with something, we want to use a wait delay ability task. Now, we could make this a tickable game object, which would give us, a similar effect, but that kind of goes beyond. I mean, it's pretty simple to do, but that's not really something I would recommend doing. And since this is a gas based tutorial, I would much like to stick with using gas inside of a ability because ability is gas and it kind of goes hand in hand with ability task if you can kind of put the names together. So, an ability task, in this case, the wait delay, you create the ability task, you activate it, and you basically give it a some sort of delay. So let's say 1. So we want this to have a delay of 1 second. So we create the ability task, activate it. 1 second later, it's going to call a function that we'd have told it to basically complete. Now, ability tasks are often used for latent operations or passing data from the client to the server and that sort of stuff. So, for a real world example, with Arc Inventory, they have a ability task used for swapping item slots. So, what you do is you have a slot to swap. So, we're just going to call it a to slot and a from slot. So, you have your ability, which you could just activate called like, I don't know, swap items. So when that ability activates, it creates the ability task inside of activate ability, and it basically just sends the to slot and the from slot to the server via target data. And we'll end up covering target data when we get into the shooting stuff because that's where we're going to use it quite heavily. But you're basically just think of it like an RPC. So you're sending data from the client to the server, and then inside of that ability task, the way it's set up is once that data has been received, it will simply fire off a function, whether or not it was successful or not. So you can handle it however you need to, such as if you need to cancel the ability if it failed, or continue because it was successful. So we're going to go ahead and do that basically now. So I want to have a function that continually calls itself using that wait delay ability task. So I'm going to make a protected section. And in here, we're just going to have void perform UI sweep. Because this function here is basically just going to be continually calling itself. So that way it can scan for, well, something to update our UI with. So inside of here, not inside of here, but we need to actually call this. And we only want to call it if we are the local player. So we don't want the server to call this for everybody. There's no point. It's just wasted resources. So what we can do is if locally controlled inside of our activate ability, we call perform UI sweep. That way we get into here if we're the local player and just start looping basically. So now we can create that ability task. So you ability task, wait delay. So you can include that with abilities, tasks, ability task, wait delay. Let's go ahead and organize the includes. And we'll just call it wait delay. And oftentimes these have their own, I guess you could say, static function that's used to curate them. So for example, here we have a static function called wait delay. Takes in a owning ability and a time. And then we have, in addition, some delegates. So F wait delay delegate on finish. So we bind to on finish. So basically when this timer has elapsed, so to speak, on finish will fire whatever function we have. So in order to create this, we use U ability task wait delay because it's a static function. Wait delay. So the owning ability is going to be this, and the time. So how, what's the rate at which we want to perform the sweep? So we'll just do 0.1. And from there, we can go ahead and bind to the onFinished. So wait delay on finish. We want to add dynamic. And we're going to add, what did I spell that wrong? We're going to add, actually this needs to make a, because we're going to call this function needs to be a U function because we're using add dynamic. But this for the object and the function is going to be U gameplay ability interact perform UI sweep. So it's going to complain that's not a U function. So let's go ahead and make it one. So U function. And now we're good to go. So after that, what we want to do is activate the ability or the ability task. So wait delay, activate, and that's it. So now every 0.1 seconds or this interval, it's going to call perform UI sweep. So we're going to continually basically be recalling our own function. So what we can do is just simply have a log. So input pressed, perform UI sweep, input ability. And that'll just kind of let us know that it is running. So I'm going to close the editor down, recompile, relaunch, and just make sure we're good to go. Okay, once I'm in the editor, I can hit play. And there we go. We are getting our, basically, our log is being spammed, and that's what we wanted. So we know that this is working. So now we can actually go ahead and make a perform sweep function because we're going to be reusing it in 2 different places, inside of here and on input pressed. So let's do make it return a bool. So if it's a successful thing we can interact with, and call it perform sweep. And we want it to pass out a hit result. So F hit result, by reference hit result. So we're going to fill in, because we're passing by value, the basically from perform UI sweep, we're going to be constantly sweeping. And if there's a valid hit, then we can go ahead and prompt the UI message. If there is not a valid hit, we take that UI message away. That's kind of the route I'm leaning towards with this. So perform sweep. And from here, inside of perform UI sweep, we simply do F hit result, and if perform sweep, pass in the hit result, then we can add UI message. Otherwise, remove UI message like so. So now we have our perform sweep. We need to make it. So we need to figure out where we want the trace to come from, which in my case, I want it to come from the camera. So we have access to the player controller through the actor info. So if you recall what I had mentioned with the setup, or where is it? Calling init ability actor info and kind of what it does and the things that it sets. This is one of those things. So it gives us access to the player controller through the actor info. So to get the actor info, we can simply do current actor info and grab the player controller. Not sure why autocomplete decided to do that. So we want to store that. So a player controller, and simply do .get because it is a weak pointer. And we can go from there. Now, instead of constantly doing this and having to fetch it, this is probably something, because we're going to be accessing it continually, that we'll want to store, but it's not too big of a deal. We have our player controller. We want to get the camera manager. So player camera manager, so that we can grab the current camera location and the camera rotation. So get camera location, get camera rotation, and store them appropriately. So const effector camera location and const F rotator, camera rotation. And that's going to allow us to create kind of our start and end points for the sweep. So the start point being the camera location, end point being a point in front of it. So const F vector, let's do sweep end, and that's going to equal the camera location plus the camera rotation dot vector. Finally, actually auto-completed something useful for once. And we want to multiply this by the distance at which we want to trace. So in my case, I'll try 250. So this should put a endpoint about 250 centimeters in front of our camera. Once we have that, we can go ahead and sweep. So get world, sweep, single by channel, and it takes in a hit result. So F hit result, hit result. So that's where it's going to fill the start, which is the camera location, the end, which is sweep end. And then it takes in the rotation, which we don't care about. So F quaternion, just make a new one. And then the trace channel. So for now, we're going to use the visibility trace channel. So ECC underscore visibility, which we'll have to expose this to Blueprint in the near future. Oh, that's right, because we have the hit result right there. We don't actually need to make a new one. My mistake. So we have the trace channel, then we have the collision shape. So F collision shape. We can make let's do a capsule, or let's see. I think it would be a sphere. No, it would be a sphere. And we'll give it the diameter of, let's try 10 for now. And we'll debug this so we can actually see, the actual trace and if we need to change it. So length, diameter, and that kind of stuff. And then everything else, for the most part, we can leave as default. So this does return true or false if it had a actual blocking hit. As you can kind of see, returns true if out hits contains any blocking hit entries. So we can go ahead and store this. So const bool be hit. And for now, we just simply return be hit. So if there was a blocking hit, we want to go ahead and return true. If there's not, we want to return false. But in the future, we're going to end up setting up a interact interface in our core module, and we're going to do a double check. So if there is a hit and that hit implements that interact interface, then we know that we have hit something that we can actually interact with. Because right now, just anything we hit is basically going to just return true for us. So what we can do from here is go ahead and try to debug this drawing, so this sweep, so we can see, what it looks like, the size, that sort of thing, and make some tweaks. So draw debug sphere. It's going to take in the world, so get world. Then the center point. Is it draw debug sphere or is it sweep? Maybe I'm thinking of capsule. Draw debug capsule. Center half height. No, let me check really quick. Okay, so it was draw debug swept sphere. So that's from the Kismet trace utilities. So let's go ahead and include that. And continue. So get world. Then it's going to take in basically the start and end like before. So camera location and sweep end. Then the radius, which in our case is 10. Persistent lines, actually color, so we'll do red. Then persistent lines false. Then lifetime. So we're going to do the delay rate. So basically this, so 0.1. And that is it. So this will allow us to visually see the actual, the trace and everything. So what we want to do is we want to expose the properties so we can tweak them. So we want to expose the delay rate, the distance that we perform the trace, and the radius of which the trace is. So basically just 3 floats. So let's go ahead and do that. So U property, actually 4, because we want the collision channel as well. So U property, let's do edit, we'll just do edit defaults only, blueprint read only, and category is going to equal interact. So we're going to have first off the trace channel. So that's going to be, in our case, the visibility channel for now, but we want to do t enum as byte. It's going to be e collision channel, and we'll call it the interact collision channel. Once we have that, we want to go ahead and do the trace distance. So float trace distance, set that to 250 by default. Then we want the trace radius, so float trace radius, and we'll do 10 by default. So that's the 3. What was the 4th? So we have the trace distance, the trace radius, and the delay. So the delay rate, which I'll actually make that one first. So float, let's do, I guess this could be the sweep interval. So 0.1. That should be sufficient. So sweep interval is going to be the sweep interval. Then we have the collision channel. So ECC visibility. Let's actually set this by default to be that. So ECC underscore visibility. Then set the trace distance, which is 250. Then set the trace radius, which is in the make sphere and the debug. So once we have all of that, let's go ahead and close down the editor. I'm going to remove this log because I know it's running, and hit go ahead and recompile and relaunch. Okay, once we are back in the editor, we need to go ahead and make a blueprint version of that ability, kind of like I had mentioned we are likely going to need before. So new ability, search for interact, and we have our gameplay ability underscore interact, GA underscore interact, same thing as before, and open it up. So now we can head to our player, go to the player state, and change gameplay ability interact to GA underscore interact, because we're using this instead. So now, if I hit play, we can see there is our trace. So that is quite a lot longer than I was expecting, but I don't know what I was expecting with 250. So that means we could, interact with the door from back here, which is quite excessive. So we likely are going to want to have that distance. So that's going to make our default. Instead, let's just divide by 2. So 125. And this is about as close as we're going to be able to get to the door and interact with it. And I think that's probably okay for now. We could likely go a little bit farther, but it's not really a big deal. So we want to change that default to 125 instead of 250. And that is going to be all for this video. So change it to 125, and we are good to go. So now that we have our interactability actually set up and functional, we can very easily move on to kind of the rest of the system. So we need to make that interact interface so we can tell, things what it can actually interact with. And from there, that's going to allow us to, 1, work on the view model for the UI, and 2, work on the actual kind of like the thought process of how do we want this interaction system to work? Because we need to, some things we can just walk up to the door, press F, and that's it. It's no longer a interactable. Whereas other things, we walk up to, say, the wall and press F, and we actually are going to get something in return. So we need to figure out how we want this to actually work. So, and same thing, the UI message actually changes for when you purchase a wall weapon. So that's another thing to take into consideration. So with all that said, I will see you in the next video. If you want to support me, Please check out my Patreon link down below. And if you want to continue along with the series, make sure to subscribe.